Good day everybody. Today we will talk about plotting in MATLAB. So we will see how we can show some graphs in 2D and 3D by using our MATLAB. So let's open our MATLAB and let's open an M file. In order to draw a graph in MATLAB, we need a couple of important things. One of them is that we have to define our x-axis, and then we have to define our function, and then which is our y-axis, and then we have to draw the x versus y. Now, in order to define x, we have a format of this form. We define our x to be a starting point, then we put column, and we write down a step size and then ending point. So for instance, I can write x starts from -2 pi with a step size of 1/10 till 2 pi. If we do not specify the step size, by default the step size will be chosen as 1. If let me save it as test 9. If I run this, you can see that we have 126 points, and these are the values for x. Now let's clear the screen. So this is my x. Now I am defining y very simply to be sine x. So after I run it, I have my x and I have my y. Now what I want to do, I want to draw my graph to see my sine function. In order to do it, I am using plot x and y, which means that I want to see the values of x in the graph, the values of y also on the graph. And when I run it, as you will see that it will open a new window, and it has the sine, which is start from -2 pi till 2 pi, and we have our sine function in here. Now in order to close this window, we can use a command called close, and we can close all the windows which are open. So if for instance if we want to only clear this, we can use something called CLF, which means clear the figure, and if we go to the figure, we see that it is empty now. Now if I don't use x and I only say plot y, you will see what happens. It starts from 0 and it goes till the last point, which as you may remember, we have 126 points. So each point is 1 unit, although we had from -2 pi till 2 pi. So in order to see between -2 pi and 2 pi, we have to specify our x-axis. Now if I don't use the step size, or I keep it as 1, which is the default, and I draw, I will see that this is my function. So it doesn't look like very nice, but in order to make it continuous and very nice, I have to make this step size relatively small. 1/10 was okay, 1/100 is alright, depends on what is the range that you have defined on your x-axis. So you can see that this is pretty nice. Now there are a few things that we have to know. Here, as you can see, the x-axis is a start from -8 to 8, but assume I want to have exactly from -2 pi till 2 pi. In other words, I want to limit my x-axis, so I can use a command called xlim, and I can say that it should start from -2 pi till 2 pi, and if I run it, I will see that now it's from -2 pi till 2 pi. I can do the same thing with y limit. I mean, it's between -1 and 1. Maybe we want to see it as y limit to be let's say minus 1.5 till 1.5, and if I run it, you will see that this time we see a better range of our function. Now, another interesting thing that we can do with our graph is I can let me put it here so we can see it. And now what I can do, I can define, let's say, X label, and I can say that this is X axis, and surely we can define similarly Y label, and we can define something which is called title. And let's call it Y is equal to sin X. And if I run this one, here I have to close this, I will see that I have a function, I have a plot which has the x-axis label, y-axis label, and the title. So you can see the location that x-axis and y-axis are appearing. Sometimes we want to have the grids to be on. In other words, we want to have the lines. For doing that, I can always write the comment grid, and when I press enter, you will see that our grids are on. Or you can do it in here inside your M file. You can have the grid. If you write it, it will be automatically on. You can write it grid minor, and you can run it. And if you do grid minor, you can see lots of small grids. Of course, you can go for grid off, and if you look at your function, your plot, you see that there is no more grids. So you have seen how you can put the X label and Y labels. Now, assume that you want to plot it, and you want to plot it in different color. In order to do it, you can write here, for instance, you want to have it in red color. Blue is the default, and if we do it, you can see that the line, the graph is in red. Now, here, as you can see, there is an icon of an arrow. And if you click on this icon of arrow, then it permits you to edit your plot. For instance, I can click on my function, and I can have a right click, and I can change the width to be, let's say, 5. I can have a right click, and I can say that I want to change the color into something else. Let's choose a purple color, and then you can click on the text. You can say that you want to change the font, and we say that the font, let's have it to be 14. Here the same thing, let's have this one 24, and you can do all other editing with your graph. So let's close this now. Assume you have let's say another function which is z equal to cosine x, and you want to see both functions in one window. In other words, you want to see sine and you want to see cosine. In order to hold and keep one of the plots while you are drawing the other one, you have to use this hold on command, and then you can have plot x and z, and let's have this one in black. And then when you run it, what happens, you will see that we have cosine and sine drawn on the same window. Now, one of the other thing is that, okay, you show the graph to someone, and you want to say that, okay, the first one, the red one, is sine, the black one is cosine. We can use something which is called legend. And in order to do the legend, the format is in this form. We have, let's say, sine and cosine. And when we run it, the sequence is important. The first one is sine, the second one is cosine. If you write cos and sine, then it will show that the red one is cosine and the black one is sine, which is not correct. So the sequence of this plotting is playing an important role. Now, or assume that you don't want to show both of them in one graph, but you want to have one window and you want to show both of them in one window but in different plots. In other words, you want to divide your plot into two. Now, in order to do it, what we can do is we can use a command called subplot. Subplot has this general format. Number of rows, comma, number of columns, comma, location. Now, and then you use the plot as continuation. For instance, I have subplot. I want to have one row, two columns. On the first place, please show me the plot, and then of sine, and then I want to have it should be subplot, and then I want to have as a subplot of 1 to the second location, the second function. Let's remove all these ones for the time being. Let's see how the command works, and when I run it, you will see that on one of them I have the sine, the other one I have the cosine. In order to have the limits and labels after each of the plots, you should have them. Let's have only the x labels. And let's call that, this is the first one is sine, the next one is cosine. And now let's run it, and what we see is this. We see the sine and we see the cosine between minus 2 pi till 2 pi. So we can use the subplot command in order to have several more plots. So if I just simply change this one into 2 and 1, it means 2 rows and 1 column. Then if I run it, we will see the graph in this form: 2 rows, 1 column. Now let's make a new M file, and in this new M file, let's see how we can draw a 3D plot. How we can draw a 3D plot. In order to do that, we have to define our, let's say, t-axis. So the variable t, let's define it to be minus 3 pi with a step size of 1 over 25 till 3 pi. And then we define x to be sine t, y to be cosine t, and z to be t. I'm sure that if you are familiar possibly from calculus with this parameterization of a 3D surface, so t is our parameter and we have the x and y and z. Now what I want to do is I want to plot it in 3D. So I'm using the command plot3, which you might be able to guess, x, y, and z. And I run it. We have to save it also. Let's call it test 10. And if we do it, we see this flex, which we have this spring shape in 3D for x, y, and z. Also, we had several other commands to use. Let's comment this one. Let's say, for instance, we have something called a mesh grid. I can define x and y to be the mesh grid for minus 3 pi 1 over 25 and 3 pi, and then I can have z to be cosine x multiplied by sine y, and then I can have mesh x, y, and z. And of course we have to comment this part. And if we run it, we will see a plane which is defined in here. You can always rotate it into the 3D form to see how it looks like. You can do the same thing for the plot tree that we had at the beginning. Well, here we have a vector, so we have to have this vector multiplication, so you can see the result in a better form. Now we can have it as, you can define any type of function like dot multiply by exp of x plus y, and see it in a form that you want to. So plot tree is what we can use. Mesh is another command that you can use. You can use labeling again in here and have very nice and colorful plots. You can use always this edit button that I have just shown you on the figure, and you can close all the windows by using the command close all. I hope that you enjoyed today's lecture. Be single.